So let us do a review. We saw that classical statistical mechanics predicted that for each mode we can associate the energy, kBt, and because in a black body we can fit in an infinite number of modes per unit volume, the energy, the total radiant energy diverges. Now what Planck thought is that he thought of the radiation being emitted by oscillators which reside in the wall of this cavity. And what he thought was that what if the oscillators, which are atoms or molecules, their frequency, their energy states are quantized. And therefore, the energy that they would radiate into the cavity would also be quantized. So Planck introduced his famous quantum formula, which was the energy would be an integer multiple of h times nu, where h is a new constant. And then what Planck saw that instead of the equipartition theorem, instead of the energy associated with each mode being kBt, he got a different result, and the result was h nu divided by e to the power h nu by kBt minus 1. So this is the result Planck got instead of the result of the classical equipartition theorem. So now, what is the energy density that this result predicts for the black body? Well, that's very easy to derive now. So the energy density at the frequency nu is going to be given by the following formula. So the number of modes counting would be the same as before. So that number is going to be 8 pi by c cubed nu squared. But now the energy associated with each of these modes is going to be given by the Planck distribution. So this is going to be our new formula. So we can, of course, now rewrite this. And if you rewrite this, it's going to give us 8 pi c cubed nu cubed times h times e to the power h nu divided by kBt minus 1. And look at this formula now, is that for very low energies, when nu is small, what we have here is that we get back the result that the classical result. And that's why, this formula fits the Rayleigh-Jeans formula for low values of nu. And but for high values of nu, this factor diverges, but this factor goes to 0, and but this factor goes to 0 much more quickly than the way that this factor diverges. So therefore, this factor, the second factor, naturally regularizes this function for the higher frequencies, and therefore one gets a finite result. So if you now plot the Planck distribution, the Planck black body formula, so you've got the energy density versus the frequency, then you get something like this, which is completely regular. So there's a tail here, sorry. So there's a tail. Anyway, and this is how Planck derived the correct formula for the black body radiation.